Download this code from codegive.com, link in the description below. OK, let's dive into evaluating limits in calculus using calculator techniques, focusing on numerical approximation and error analysis. I'll provide a comprehensive guide, including methods applicable to various calculators, TI-84, Casio FX series, numberworks, etc., and Python code examples for more advanced scenarios. Understanding limits, a conceptual foundation. Before we jump into calculators, let's solidify what a limit is. The limit of a function f, x, as x approaches a value of, written as lim x rightward arrow a f, x, equals L, is the value that f, x, approaches as x gets arbitrarily close to it, but not necessarily equal to it. The function itself might not even be defined at x equals a. Key concepts asterisk. Asterisk approaching from left and right asterisk. We need to consider the limit as x approaches a from both smaller values, x rightward arrow a, and larger values, x rightward arrow a plus. If these one-sided limits are equal, then the overall limit exists. Asterisk indeterminate forms asterisk. Many limit problems involve expressions like 0/0, infinity/infinity, 0 asterisk infinity, 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 1 caret infinity, 0 to the power of 0, infinity caret 0. These are called indeterminate forms. They don't immediately tell us the limit's value. We need techniques, algebraic manipulation, L'Hopital's rule, etc., to resolve them. Asterisk calculator limitations asterisk. Calculators are numerical tools. They approximate limits by plugging in values close to a. They cannot provide rigorous proofs or handle all types of limits, example involving functions with complex behavior near a. 2. Calculator techniques for approximating limits. The general strategy is to evaluate the function near the point where we're taking the limit. This is done by entering your function into your calculator and using a variety of different methods, which will be discussed below. A simple numerical substitution, manual. This is the most basic method. 1. Enter the function asterisk. Input the function f, x, into your calculator's function editor, often accessed through a y equals menu. 2. Choose values asterisk. Select values of x that are very close to a from both sides, a and a plus. For example, if you want to find the limit as x rightward arrow 2, you might try x equals 1.9, 1.99, 1.999, and x equals 2.1, 2.01, 2.001. 3. Evaluate asterisk. Use the calculator's table feature or simply substitute each x value into the function to obtain corresponding f, x, values. 4. Observe the trend asterisk. As x gets closer to a, observe what value the f, x, values are approaching. That is your estimate of the limit. Example, TI-84. Find lim x rightward arrow 2, x caret 2, 4, slash, x, 2. 1. Enter y1 equals, x caret 2, 4, slash, x, 2, into the y equals menu. 2. Go to table set, second plus window, and set TBL start to 1.9 and delta TBL to 0.1. 3. Go to table, second plus graph. You'll see a table of x and y1 values. 4. Adjust TBL start and delta TBL to get values even closer to x equals 2, example TBL start equals 1.999, delta TBL equals 0.0001. 5. Notice that the values of y1 approach 4 as x gets closer to 2. B. Table feature, automated substitution. Most graphing calculators have a table feature that automates the process of calculating function values for a sequence of x values. 1. Enter function asterisk same as above. 2. Set up table asterisk. Asterisk tbl start asterisk specify the starting value for x in the table. Asterisk delta tbl asterisk specify the increment between x values in the table. Asterisk and asterisk make sure it's set to auto so the calculator generates the x values. 3. View table asterisk access the table, usually 2nd plus graph on TI calculators. 4. Adjust and zoom asterisk adjust TBL start and delta TBL to zoom in on the region around a. You might need to manually scroll up or down the table to find values closer to a. See graphing and zooming. Visualizing the function can be helpful. 1. Enter function asterisk enter the function f, x, into y equals. 2. Set window asterisk adjust the window settings to display the region of the graph near x equals a. Pay particular attention to the min and max values to ensure the graph's important features are visible. 3. Graph asterisk press the graph button. 4. Zoom in asterisk use the zoom menu, especially zoom in or zoom box, to magnify the graph near x equals a. 5. Trace/calculate value asterisk use the trace function or the calc menu, second plus trace, to evaluate the function at specific x values near a. The value option in the calc menu can be very helpful. D. Using the solve function, carefully. Some calculators have a solve or equation solver feature. While not directly designed for limits, you can sometimes adapt it. 1. Rearrange, if necessary sometimes, you can rearrange the limit expression into an equation. 2. Enter equation asterisk input the rearranged equation into the equation solver. 3. Solve near a asterisk provide an initial guess for the solution that is very close to a. The solver will try to find a solution near your guess. Be careful, the solver might find a different route or fail entirely, especially if the function is not well behaved near a. 3. Example problems and calculator steps, TI-84 plus CE. Let's work through a few examples using a TI-84 plus CE. The same principles apply to other calculators, but the specific menu names and keystrokes might differ. Example 1, lim x rightward arrow 0 sin, x, /x. 1. Enter function asterisk y1 equals sin, x, /x. 2. Table method asterisk. Asterisk 2 nd plus window, table set tbl start equals dash 0.1, delta tbl equals 0.01. Asterisk 2 nd plus graph, table observe the y1 values as x approaches 0 from both sides. They appear to approach 1. Asterisk adjust tbl start and delta tbl to get closer to 0, tbl start equals dash 0.001, delta tbl equals 0.0001. The values are even closer to 1. 3. Graphing method asterisk. Asterisk window, sets min, smax, imin, imax to appropriate values, example smin equals -1, smax equals 1, imin equals 0.8, imax equals 1.2. Asterisk graph, observe the graph. Asterisk 2 nd plus trace, calc choose 1, value. Enter x equals 0.001. Enter x equals dash 0.001. The y values are close to 1. The calculator will show a blank spot or error, divide by 0 if you enter x equals 0 directly. Example 2, lim x rightward arrow infinity, 1 plus 1 / x, caret x. 1. Enter function asterisk y1 equals, 1 plus 1 / x, caret x. 2. Table method asterisk. Asterisk 2 nd plus window, table set TBL start equals 100, delta TBL equals 100. Asterisk 2 ND plus graph, table observe the y1 values as x gets larger. They appear to approach the mathematical constant e, approximately 2.718. Increase TBL start and delta TBL, example TBL start equals 10,000, delta TBL equals 10,000, to confirm the trend. Example 3, one-sided limit. Lim x rightward arrow 0 plus sqrt, x, asterisk ln, x. 1 enter function asterisk y1 equals sqrt, x, asterisk ln, x. 2 table method asterisk. Asterisk 2 nd plus window, TBL start equals 0.01, delta TBL equals 0.01. Asterisk 2 nd plus graph. 3 You should see the value of the function decreasing and going to negative infinity. If you decrease the start and delta TBL, you will notice the value approaching 0. 4. Python code for limit approximation. Python, with libraries like SymPy and NumPy, provides a powerful environment for approximating limits and performing error analysis. Explanation of Python code asterisk. 1 SYMPY library asterisk SYMPY is for symbolic mathematics. It can find exact limits, if possible, using analytical techniques. We use SP symbols to define symbolic variables, SP simplify to convert a string into a SymPy expression, and SP limit to compute the limit. 2 numerical underscore limit function asterisk. Asterisk takes the function, approach value, and a delta, small increment, as input. Asterisk creates x underscore values underscore left and x underscore values underscore right arrays of x values approaching approach underscore value from both sides. Asterisk calculates the corresponding y underscore values underscore left and y underscore values underscore right by evaluating the function at those x values. Asterisk averages the 10 points closest to the center on both sides, as this gives the most accurate approximation for what the numerical value converges to. Asterisk prints the value for what the numerical approximation converges to, the error, and also gives all the values, which will be used for plotting. Asterisk returns the arrays of x and y values for plotting and analysis. 3 Error analysis. The code compares the left and right limits to check for convergence. 4 Plotting asterisk matplotlib.pyplot is used to visualize the function and the approximation process. This helps you see how the function behaves near the approach value. 5 Example for one-sided limits asterisk. The example takes the function sqrt, x, asterisk ln, x, and finds the limit as x approaches 0. Note that there is code to prevent division by 0. Important considerations asterisk. Asterisk choice of delta asterisk. A smaller delta generally gives a more accurate approximation, but can lead to numerical instability, example division by very small numbers. Experiment to find a good balance. Asterisk discontinuities asterisk. Pay close attention to functions with discontinuities or singularities near a. The limit may not exist, or the calculator might give misleading results. Asterisk L'Hopital's rule asterisk. Calculators don't directly implement L'Hopital's rule. If you encounter an indeterminate form, you'll need to apply the rule algebraically and then use the calculator to evaluate the resulting limit. L'Hopital's rule says that if the limit as x approaches of f, x, /g, x, is in the indeterminate form of 0/0 or infinity/infinity, then the limit as x approaches of f, x, /g, x, is equal to the limit as x approaches of f, x, /g, x, assuming the limit on the right exists. Asterisk asymptotic behavior asterisk for limits as x approaches infinity or negative infinity, choose sufficiently large, or small, x values in your calculator or Python code. Asterisk rounding errors asterisk be aware that calculators and computers use finite precision arithmetic, which can introduce rounding errors. Common mistakes and troubleshooting. Asterisk incorrect function input asterisk double check that you've entered the function correctly into the calculator or Python code. Parentheses are crucial. Asterisk incorrect window settings asterisk if you're graphing, make sure the window settings show the relevant portion of the graph. Asterisk not approaching from both sides asterisk always check the limit from both sides, x rightward arrow A and x rightward arrow A plus. A limit only exists if the one-sided limits are equal. Asterisk assuming a limit exists asterisk just because the calculator gives a value doesn't mean the limit actually exists. The function might be oscillating wildly or approaching different values from different directions. Asterisk ignoring indeterminate forms asterisk recognize indeterminate forms and use appropriate algebraic techniques, or L'Hopital's rule, before resorting to calculator approximations. Asterisk rounding errors asterisk be aware of the limitations of calculator precision, especially when dealing with very small or very large numbers. 6. Conclusion. Calculators and Python are valuable tools for approximating limits in calculus. They allow you to explore function behavior numerically and visually. However, it's crucial to understand the limitations of these tools and to use them in conjunction with analytical techniques and a solid understanding of the concept of a limit. Always check your results critically and be aware of potential sources of error. Good luck.